Hello everyone. Today let's discuss about microstrip antennas. In the antenna world, microstrip antenna plays a very important role, which is constructed basically by having a dielectric material, a substrate, and a conducting patch and a ground plane at the bottom. There are a lot of desirable and undesirable features when we consider a microstrip antenna as a radiator. Looking into its advantages, it is very compact, it has a very low profile, and very ease of integration with other PCB or other RF transceiver devices. When we look into the disadvantages, the first thing what comes is it has a very narrow bandwidth, which is not good, and then which gives rise to low radiation efficiency. So, is this? What is causing this narrow bandwidth? Let's discuss more on it. So, when I consider microstrip antenna, we have two types: traveling wave type and resonant type. So, when I concentrate on resonant type of microstrip antenna, which is a lot used in the antenna design, it has a well defined radiation characteristics. But then again, it suffers narrow bandwidth. So, why is this happening? So when I consider a printed patch antenna, it's basically having a conducting ground plane, yeah, which means this stores electrical charge and energy and it acts as a reactive circuit element. Something to think about, yeah. So this ground plane, electrical conductivity, causes the image effect of the patch and hence it limits its bandwidth. So this limitation of bandwidth consequently gives rise to uh, what is called as the behavior of the substrate itself. So, what should be the substrate parameters? What should be the thickness of the material I chose, which in turn is giving a huge impact on me deciding whether I need to have a bandwidth constraints. So, in this small talk, let's discuss about the effect of the dielectric substrates what we choose, which in turn has a huge impact on the bandwidth itself. So whenever we start designing an antenna, it's basically like what's economically available. So what's there for me so that I can design, fabricate, and test it and use that product what I'm supposed to design for an antenna. So when we are doing this, so few more other things to be kept in mind, that what kind of substrate do I need to choose so that I have a better bandwidth also. So few of the techniques, if I have to see, if I have to think about concentrating more on how to increase the bandwidth, two ways, two techniques. One is structural, which mostly relates about what kind of substrate material I choose, what should be the antenna shape and everything. And then comes something called as circuit theory, which evolves from our network theory principles, which I inculcate in my antenna design for my impedance matching and many more things. Today, let's mostly concentrate about structural techniques which can be used to increase the bandwidth. One is, as I already mentioned, the substrates, the substrate parameters and its behavior and everything. And then comes what kind of shape do I choose when I'm talking about the antenna. So what should it be? Square? Should it be rectangular? Should it be circular? So that I get a broader bandwidth. And then comes a different type of slots which I can append on this antenna structure itself. And then we are all talking about the latest, which is running over the decade with respect to electronic band gap and metamaterials. So these metamaterials, man-made structures, induces other electromagnetic boundary conditions. It could be with respect to perfect magnetic conductor or a reactive surface itself. So when this other kind of electromagnetic boundary condition arises, so this modifies the image effect and electrical property of the patch antenna itself, which helps me in changing the bandwidth and radiation efficiency. So when I consider that it's changing, which means now I have the liberty to control my bandwidth also. I can tune it, I can design these structures in such a way that I get a bandwidth desirable as I want it, which otherwise wouldn't have happened in a normal printed patch antennas. So let's get into a very small topic of structural techniques in which I can control the bandwidth is with respect to substrates. So when I choose a substrate, the first thing which I have to be careful is what is the permittivity of it, what is the thickness of it, which directly influences the bandwidth. So when I consider a smaller thickness of the substrate, patch antenna is mostly viewed as a lossy capacitor. Yeah. So keeping this in mind, if I want to have a patch antenna as an energy storage device, so what I'll do is I'll increase the substrate permittivity and I'll reduce its thickness. So good for me when I'm talking about an energy storage device. But then again, what happens? So this definitely increases the antenna quality factor, but it also reduces the bandwidth. Why? How is this happening? So when we look into this equation, it says the antenna quality factor is directly dependent on the energy storage. Yes, but then again, I have a reverse relation here. The moment Q increases, the bandwidth of the antenna will decrease. So what does this mean? So does this actually thing mean that I have to start decreasing the substrate permittivity and increase the thickness of the material what I have chosen? Can I do that? So what happens if I do that? So if I decrease epsilon r and start increasing the patch thickness, the substrate modes become excited and it will cause undesirable polarization and radiation pattern, let alone changing the higher order, creating the higher order modes in the patch antenna itself, disturbing the actual existing polarization and radiation pattern. So this is like a very small observation or a video which is put out just to bring a curiosity that a diagnosis is done, an attempt is done to understand that substrate plays a very, very important role if I have to consider a bandwidth in mind for my better huge data transmission and everything. So here I would like to end my talk giving a question in the mind that substrate definitely has an impact on the bandwidth. And in my next video, we'll discuss about what are the techniques which can be used to iteratively have a better bandwidth and hence high data transmission rates. Thank you so much.